Hello, good day. My name is Topman Paul-Dike, and in this section, I'm going to be continuing from where I stopped on pointers, arrays, and string. Please, if you've not seen the other video, you need to see it, as I may not be repeating certain things that I said in that one here. This is a continuation, right? So let's proceed with types and memory. These are the primitive data types in C: int, float, char. You know them, right? How that int takes 4 bytes, float 4 bytes, and char 1 byte. I talked about this in the previous video. You might want to watch that one and then come back to this place. One problem with students, is how that they want to learn. They want to really know the thing. They want to learn, but they want to learn it by miracle. Something that's supposed to take you so much time to learn. You want to learn it in 15 minutes. So you're looking for the shortest video, shortest tutorial, and you just may not learn it very well like that. You just may not. So if you really want to learn this thing, give it time. Give it time. You know, some persons are amazingly not even not. Some persons not even have enough time to learn. That's amazing. That's amazing. But if you really want to do this thing, give it time. Okay, give it time. Let me show you this. You might be interested in it. I have a repository where I push these codes to. So it's called the part to see. So you find any code you write here, you find it here if you want to play with them later, and you will find the link to this repository in the description of this video on YouTube. Okay, I also have another repository here, the journey through C, where I took several concepts on C. Okay, pointers is not here. Oh, pointers is here now. Pointers are real string. You might want to look at it as well and learn some more. Okay, let's proceed. Types and memory. Now I presume that you know by now that int, although the size depends on the machine in use, right? But on my system here, it is 4 bytes. So on most 64-bit architecture, it's 4 bytes that it takes. Right? This one takes 1 byte here. So what are bytes? Am I going through that again? Now, you've got to understand that these guys occur. A byte is made up of 6 bits, which are sets of zeros and one. Right? Sorry, 8 bits rather. 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. This represents 8 bits, which is equal to 1 byte. So when we say char is 1 byte, we're saying that when you declare a character, it has 8 bits like this. That character can be represented with sets of zeros and ones. There are 8 digits. Right? You can't be more than 1. You won't see 2 here. It's either 1 or 0. Okay. So if you want to know the range or the number of values that might likely occur as char, this is it. Let me do this small arithmetics. I hope this does not confuse anyone. If I do 2 raised to power 1, if I was referring to 1 bit, right? Because that bit can either be 0 or 1. It means there are 2 possible occurrences. It can either be 0 or 1. So 2 possible values. 1 bit has 2 possible values. That's how we can represent it as 2 raised to power 1. Okay, so and if I did 2 raised to power 2, for example, then I'm referring to the possible values that can be found in 2 bits. All right, what I mean is this: 2 raised to power 1 is equal to 2. So we are saying that one of these bits can have only 2 possible values, which are 0 and 1. 2 raised to power 2 is equal to 4, right? 2 raised to power 2 means 2 times 2. You know that, right? So it means there are 4 possible values, for this particular for two bits, 4 possible values. Now, what are the 4 possible values? Let's try and find out. We can have them as 0 0. We can have it as 0 1, right? We can have 1 0, and we can have 1 1. These are the only 4 possible values that can occur when you're dealing with 2 bits, right? I hope you understand that. I hope that's well communicated. Now, what if we are dealing with 3 bits? Let's find out the possible number of values. And we can have that will be 2 raised to power 3. 2 raised to power 3. Okay. And 2 raised to power 3 will be 8, right? That will be 2 times 2, 4. 4 times 2, 8. So, I want to find that. It means when we are dealing with 3 bits like this, if we start combining this thing, forming different combinations that are possible, you discover that you end up having 8 of them. 8 of them. That's where the 2 raised to power, let me put dot here. That's where the 2 raised to power 8 comes from. I mean, to know the possible number of values that car can have, it is 2 raised to power 8 because you're dealing with 8 bits. Each car has 8 bits. So when we do this, you'll find out that you can have 256 possible values. You can calculate to find out what is 2 raised to power 8. What is 2 raised to power 8? 256 possible values. And because you want to consider the range from the negative to the positive, if we divide this thing by 2, if we divide 256 by 2, the answer will be, let's say, over 2. Okay, I don't want to confuse us. Let me just end this one here and say 256 over 2 is, of course, it will be equal to 128. 128. It means this now helps us represent the range of values that you can have, right? So it will be ranging from -128 to, let's say, to plus. It would have been +128, but the reason it's not +128 is because we count 0 as well. We count 0, so it will be 127. Let me explain what I mean by that. Easy. No confusion. Don't worry. Follow me. Hey, duplicate this stuff for me. Come on. What I mean by that is, if I say we have, let's say, 6, we're working with 6 as a maximum value, right? I want to represent the range as from -3, right? If you're going to count 6 different values, we're not going to have it up to 6. What I mean is this: -3, -2, -1, 0, 1, 2, 3. If you count this thing now, we'll have more than 6 values here, because this is 1, this is 2, this is 3, 0 is also a value, so this is 4, this is 5, this is 6, and this is 7. Hence, this one is not needed. You see? So this is it. That's why we have from -128 to 127 for unsigned. The keyword is unsigned. Unsigned means it accommodates signed rather. Signed values. There is unsigned, there is signed. When you hear unsigned means the values are positive only. Let me put it here: positive only. Only positive values. So if it were positive values, then we'll have about 555, because you have to count 0, and in counting 0 you will add the last value here. But when it is signed, you have from -128 to this. That's why you have it that way. Okay, so if I do a similar thing for okay, I don't like deleting. You're going to see a link to this whiteboard as well. on the description so that you can take a look at it. That's why I don't want to delete the things I am doing now, so that you can always come back and refer to it. Okay, so I think I will copy. All right, I think I will use a new space. Let me use a new space and demonstrate that of int. Right, we are assuming now that it's we're working with int as 4 bytes. Okay, right, so int being 4 bytes, remember 1 byte is equal to 8 bits, right? Then what will 4 bytes be? Did I say 1 byte? 1 byte. What will 4 bytes be? 4 bytes will be equal to 8 times 4 bits. Or let's say 4 times 8 bits rather. 4 times 8 bits. What would that be? 8 plus 8, 16. 16 plus 16, 32. That's it. It is equal to 32 bits. So when we want to find out the number of values possible, that number of variables that an integer can accommodate in a machine where each integer where the size of each integer is 4 bytes, then you want to do this because each byte has a possible can have 2 possible values, 0 and 1. You do 2, then raised to the power of what now? 32. That's interesting, right? That's interesting. If you put that value together, if you calculate it, you're going to get 4 billion 294 million and 294 million 967 then 296. I don't have this in my head, right? I don't have it in my head. I'm using the calculator right now. So if you divide this by 2, right? If you divide this by 2, let's say, let me copy this. Okay, so let me now divide it by 2 here. Over 2, you're going to have this 2 billion 147. I like to put this commas here so we can easily figure out. We can easily what now? No. The value. All right, so this is it. 2 billion 147 million 483,648, right? Why am I dividing it by 2? I want to know where the negative value will begin from if it is unsigned. That's why I'm dividing it by 2. So it means if we are dealing with unsigned, when it is signed rather. So if we are dealing with signed integers, it's going to have a range. Let's say range of. Okay, let me just say signed integer. Signed integer. Signed int is going to have a range of from minus. Did I copy this stuff right now? I should have copied it. Alright, this to this, but of course it will stop at 7, not 8, because we will count 0. Then when we are dealing with unsigned int, the value will just be this minus 1. So it will be this 6 will turn to 5 because we will begin from 0 to count, right? And then C programming, we don't need to indicate that this is signed. Just put int and then it knows it's signed. That's interesting, right? Now this is sound like a sound. See, if you really want to understand, if you really want to become a software engineer, you really want to know how to manipulate these things, how these things really work, then you want to pay attention to those things. All right. The reason I'm doing this is certain persons find this strange. They find this strange, and few persons will pay attention to this point. Yeah, because they want me to start doing this is pointers as I've shown you. Pointers do this, pointer does this, and then straight to the point. Be one. Some people, a lot of persons want some 4 minute video or 10 minute tutorial at most. But if you've watched up to this point, congratulations! It means you're in for a great time. Yeah, in for a nice time. Okay, the next thing I want to talk about now is story memory. Okay, I've talked about story memory addresses, right? Let me be taking note of the things I'm covering here. Let me make some space here and add storing memory addresses. You know that's the definition of pointer, right? Pointers are special variables that store memory addresses, right? They store address in memory. Okay, not that address in memory may not have um, anything saved there. It may be empty. It may not even be assigned to a variable, a normal variable. Okay, so it's beyond being able to save the address of a variable inside it. Okay, it saves address, variable or no variable. It saves address. It's a special variable that saves address. I don't know whether that point is clear. But this particular one, I think I discussed it in the last video, so I wouldn't go there. I wouldn't go there for today. I demonstrated it, so you want to take a look at it, watch it, and then I also demonstrated dereferencing. Dereferencing. What is dereferencing? Dereferencing is about being able to manipulate the value stored in a particular address in memory. Just because the pointer does not only have access to the memory, it has the memory address and it has access to the content of that memory. It can manipulate it. It can change what is there. It can show you what is there. That's pointers for you. And then I'd have loved to talk about function parameters. Being passed by value and being passed by reference, things like that. But I'm going to skip that for a reason, because I don't want to stay too long in as much as I want to teach you and I want us to learn. So let's talk about arrays. Arrays. What are arrays? Arrays is having the same data type, having multiple values of the same data type. Saved in, how do I put it, in what should I use now? Saved together, right? Saved together as a single variable. That's what I was looking for, but I did not remember. Array is if it is a data type of type int. If I want to have, let's say if I want to save from 1 to 10 inside one variable, how possible is that? I can do int number and I will say it's equal to 10. Okay, 1. And I go again, int number equal to 2. And of course it will be int number again. Let's say int number 2 equals 2. But then I can save all of this in one variable. How? By doing int number. I call it numbers this time. You can choose to call a variable anything you want to, and I say it's equal to, I'll put 2 curly braces here, and inside them I'll put the numbers I want to save. 1 2 3 4 5 6 7 8 9, and if you add the 10, separating them with comma. I don't have to put comma after the last one, right? And I'll end it with semicolon. So this is me having I'm having 10 variables inside, 10 data, 10 integers, okay, all right, 10 values saved inside one variable. So array is that kind of variable. We'll say array of something. This is an array of integers. So how do you declare it? First, you state the data type. You can see I stated data type here, and then you give it the name that you want to give it, you wish to give it, and then you must put this square bracket here, open and close this square bracket. In fact, you are supposed to indicate the size, because this thing is 1 2 3 4 5 6 7 8 9 10. So you indicate that, oh, my array is of size 10. So when you say it's of size 10, the compiler knows that, okay, you mean that I want to assign, you mean that you are saving something that has, that each one represents 4 bytes, and there are 10 of them. So it will create that space for them and put that thing in memory. Let's reduce it a bit and do some illustration. Let's say we have an array like this that has only 1 2 3. It will go and create this kind of space in memory for it. I will demonstrate that shortly, and of course I have to indicate here that it's size 3. Nothing will go wrong if we say size 10 and give it lesser anyway. So size 3, and this is it. So what happens in the computer memory is that it will go to it will assign an address at random for it, right? I would have had some random values here, but this spot could be, you've seen, if you've seen by now, you should have seen memory addresses being printed, right? It looks something like 0x, you will see 0x7, F, you'll be seeing combination of letters and numbers because they are hexadecimals. Hexadecimals, okay, let's not go there for now. So that's, just imagine that that's what is represented in all these places, right? All these places. And then because we declare the variable, and the variable name of the variable is numbers, it will go in memory and create a space for it. And that numbers, since we've stated that there are 3 of those variables inside here, this is what will happen to them. And so if it will come here and clear, and okay, let me demonstrate that. Let's say it came here, it will not clear 1 2 3 4 bytes for the first one, right? Okay, 1 2 3, let me do it like this. 1 2 3, this is the value, this is the variable. So for the variable will take that 12 bytes, which is 4 times, remember 4 times 4 times 3 is equal to 12 bytes. Alright, so we're trying to assign 12 bytes. Okay, so 1 2 3 4, 1 2 3 4 bytes, 1 2 3 4 bytes. Make social media, and 1 2 3 4 bytes. All right, 1 2 3 4. I hope this is correct. 1 2 3 4, 1 2 3 4, 1 2 3 4. That is 12, right? Okay, I think this is cool enough to demonstrate how this kind of works. So I will duplicate this and indicate how that mod variable numbers has been saved here. So this space now, the variable is allocated some memory space at random at runtime, and then this is it. It takes this space. So this variable we have declared now has created space for these 3 integers, and then the integers themselves will be saved in these spaces. The first number we had was 1, so 1 will be saved in this page, in this space where it takes the 4 bytes, and then 2 will be saved here. See, someone will stay in the center. Look sweet. And then 3 will be saved. Hey, will be saved here. Okay, all right. So this is what happens. Something like this happens in the computer memory. In a way, you declare a variable like this. Now, what will happen? I mean, this is different from if I had done something like this. Let me say, let me take. If I had done something like, let me take this one off. and say 1, 2, 3. If we do something like this, if I try to find the size of this guy and try to find the size of this guy, what do you think the size of this guy will be? Actually, 1, 2, 3, this is 123. This is 1, this is 2 and 3. This is 1, 2, 3, this is 123. So this whole thing is one number. So the size of this guy, size of numbers, okay, number, let me call it number, will certainly be equal to 4 bytes. Let's find out. We're going to code. Let's go to the terminal and code and see. So I'm going to open a file, pointer to C. It already has this boiler plate. I'm going to declare those two variables here. So I'll say int number equals 1, 2, 3. And I'll say int numbers size 3 equals 1, 2, and 3. Okay. Now let's try to find out what is inside there. So let's do a printf. Okay. So I'll say number, or let's say size of number. Let's say the size of number, the size of number, and put percentage %d here to print the value. Is it percentage %d? No. Is that it? We'll find out. Size of, I'm calling the function here now. This is the function that tells us the size of a particular, of anything, right? Of anything. Size of number, and that will do for now. Let's copy this and have it pasted here, and this will be size of numbers, right? And size of numbers. If there's nothing wrong with this code, it should work. So I'm going to save it, I'm going to minimize it and come here, try to compile it. Compile pointers for me, give me the output as size of. All right, let's go. It compiled that error, so let's try to run it now. Oh no, I did something I don't like. I should have added new line. So let me add a new line, /n, /n, save again, minimize, compile again, no error. Now run my executable for me. Size of, so it says size of number is 4. Can you see that? 4, 12. Isn't that interesting? Isn't that interesting? I mean, one would have thought that, oh, they're the same numbers, to be the same thing. There are 3 numbers here. No, there are no, it's not 3 numbers here. It's one number. 1, 2, 3, 123. There are 3 numbers here. There are 3 numbers here. It doesn't matter, so long as the number is within the range. It doesn't matter whether this was 100 and 2000. You know, it will still produce the same results. Whether 2000, 2001 takes the same 4 bytes in memory. That's quite interesting, right? That's interesting. Let's talk more about arrays. I've just shown you what happens in memory when you declare an array. And now let's do something more with arrays. How do we print arrays out? How do we print out arrays? What more do I need to tell you about arrays? You can have an array of floats, you can have an array of characters, you can have an array of course we'll come to that, array of characters. You can have an array of strings. Let's try to print out members of these arrays. How do you print out members of these arrays? For the other one, you know, it's easy. Let me change this program to, okay, I don't like changing programs like that. So that you can see it. If you come, I think I'd rather comment it off. So I will turn this to a comment. I will copy this, by the way. turn this to a comment, and this to a comment, and I thought I copied this before. So I'll paste this here, yank it here, and then I want to print out the value of number. So I'll say value stored in numbers. What am I doing? Okay. I think I want to add bytes here, just so that it makes more meaning in case you want to work with the code. So value stored here, of course, is an integer, so %d, and we address it to this variable. Okay, I think everything is cool. Value stored in number. All right, let's also print out the value stored in numbers. All right, let's see. Would this work? Let's find out. So if I try to compile that guy again, GCC, let me call this one array. So there's a problem here. Why is that? Let's take it by bit. I'll save this, minimize again, compile again. There are no errors this time. So we have array there. If I run the executable file array, it says value stored in number is 1, 2, 3. So why am I unable to print the value stored in the array? You don't print it like that. It's not printed like that, So let's go back to that file. Now, how do I print it? Let me go back to the whiteboard and show you something. There's something called indexing. So I'll call this array indexing. This doesn't sound nice. Let me call it array indices. Indices is the plural for index, right? Okay. So it is that thing that makes us know what it's about is this. Let me show you what it's about. Let me change this back to what it used to be and copy it, paste it here. How does indexing work? Indexing is about assigning values, position, identifying the positions of these elements with numbers. This one will be 0, this one will be 1, this one will be 2. When you're indexing, you begin from 0. So it means that in the numbers, now numbers has compartment, as you can see on this diagram here. It has compartments. This one is called 0, this one is called 1, this one is called 2. Right? So you start numbering them from 0. So if I say, hey, give me what is there, what is saved in array, what is saved in numbers index 0 at position 0, it tell me is this guy 1. If I say what is saved at position 1, it will give me this guy. Let's find out my code. Let's code it now. Let's uncomment this guy, and then value stored in numbers 0. Right? Let's now change this to numbers 0. All right. Save it. Minimize. Compile again. No error. Our executable is there. Let's now run it. So you see, value stored in number 0 is 1. We're accessing it now using the index. Let's now do some more. It means that I can have this. Come on, what did I just do? I can have this pasted here and pasted here. Then I will change this one to 1. By the way, let me show you something. This thing we are typing here is just string. It's not doing anything. It's just what we want to appear, right? what you want to appear. This is what is actually calling the value. This one that is you put after the comma, right? So let me leave it like this, wrong, like this. It will still print what is here. Let me show you what I mean. All right, I just compile, run it. You can see value stored is value stored in number 000. Is saying so is actually this guy that is after this guy that is the second argument is what is working it, right? This one is just the way you want it to show, nothing special except this percentage D and this backward slash n for new line. Percentage D will go and print is the format specifier to specify the format in which this thing should be printed, you know. And so let me just correct it now. 1 2 compile again, clear the screen, run it again. All right, so it's working well right now. So how do I, can't I just print all of this stuff one time? Can't I just print at the same time? Do I have to print it one? What if it's a large array that has 20 elements inside? Will I start putting 20 printf to print one thing? Well, to solve that problem, use a loop. You iterate through it and print them all out. What do I mean by that? I assume that by now that you know about loop, I'm going to explain a bit, right? So instead of doing all of this stuff, I think I want to turn all of this into a comment. I will take this one down because I will need it to print and get printed, and I will take off this space here, and I will turn this whole thing into a comment. All right, so and then let's now create a for loop. Nothing strange has happened here, right? Let's create a for loop. So for we need to have an iterator, right? Let's declare a variable that we use to iterate through it. So let me add it here, comma. Okay, let me not confuse anyone. So let's say int. Let's say index. Yeah, index, and then let's use the popular for loop. So for index, that means index equal to 0, give index the initial value of 0, and as long as index is less than, now we know the size of our array is 3, right? So so as long as it is less than 3, keep incrementing it. I mean, keep adding 1 to it. So index plus plus, keep adding 1 to it, and as you're adding 1 to it, what I want you to do is this. Is, let me paste this here. Is to print. Let's do percentage D here. All right, and what do we do here now? I have to give it 2. I will explain this. Hold on. I will explain this. Index, comma. All right. And after doing this, I want you to come out of this loop and print a new line. No, I think it's okay. This is okay. It's okay. All right. What is happening here? I'm saying that so long as index is equal to 0, sorry, what as long as let index be equal to 0, and so long as it is less than 3, keep incrementing it, and each time you increment it, perform this function here. So when index is 0, this percentage D will go and print. Oh, that's a mistake here. This should be index. It should be index, not index. It will go and print index, which is 0, right? To print value stored in number, right? This percentage D will turn to the value of index, which is 0, right? And then it will now go and print this percentage D will be number index. That means number 0. This guy here, you know, position 0 of numbers. And then after doing that, it will come out and run again. It will not carry out this action and increment index, index will not be equal to 1. 1 is still less than 3, so it will come back here again and do this thing, but at this time 1 will print here, right? And the value of numbers 1, which is this, is what this is going to be. Number index is going to be numbers 1. It will come again, increment it, index will not be equal to 2. It will check, index is still less than 2. It will come and print 2 here and print this numbers 2 here, right? And then it will come and increment it, and index will be equal to 3. Now when it comes here and check, index is no more less than 3, index is equal to 3, though this is no more true, it will not do anything here again. It will break out of the loop and it will come here and return 0. When you hear return 0, we are saying end the program here. Return, end the program, right? 0 means tell us that the program was successful. Let's use 0 to know that okay, the program was successful. All right, let me save this now and try to run it. Minimize again. Let's compile again. Something is wrong. Okay, this is wrong. It should be numbers, not number. Numbers. All right. Let's now compile again. So you compile that error. Let me clear the screen. Show you is there. Let's run it. What is happening? Something is wrong. Something is definitely wrong. Let's find that. Interesting. Okay, let's go back. What happened here? What went wrong? What went wrong? What went wrong? What happened to the index numbers? Index. Okay, it looks strange. We declare an integer index, and we say the index is equal to 0. So long as it is, increment it. I don't seem to get what is wrong. What am I not doing right? Index, number of index, numbers. What is wrong? Wow, who has seen what is wrong? Bam, 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 bam. Okay, there seems to be something I'm not doing right. Okay, I'll just rewrite this code. Let me close this editor. Open it again. Int number is this, int index is this, int numbers is this, value for index is this. I want you to print this. All this. What is wrong? I don't see what is wrong. What is the matter? What is the matter? Okay, let's change the name of that variable and see if anything gets better. Could it be that index is a keyword in C? IDX. So IDX and IDX. All right. Same thing. Wow. Oh, he printed it and kept incrementing. Why? So he did what I asked it to do, but it was doing more. Getting some more numbers. Why? And these are some garbage values, I guess. Picking values at random in my system. Okay, let's find out why. Oh, I can see why. I can see why. Alright, so this is wrong. I shouldn't say 0 less than 3. It's IDX less than 3. Quite interesting, right? Let's do that again. Compile array. Okay. So here we go. Everything is working as expected. Right. Okay, so I need to call your attention to the fact that because we can reference each of its elements, we can actually change what is there, right? We can change what is there. We can go to the program and say, hey, let me come here and say, before I do this, and say, let numbers, that's what is said as at index 1, which is the second element, right? Let it no more be 2, let it now be equal to let's say 10. If I do this, let's see what this can will print. After doing this, I will save it, minimize, go and compile and run it again. See that? And this one is now 10. This one is not 10. You don't try to assess what does not exist. You get garbage values. You get random values, right? Because something might be there. 0 might be stored there. 1 might be stored there. Some large large negative or positive value can be stored there. Okay, that's it about arrays. I think that's about all right. About all. Another thing you want to know is that array is not a pointer. Array itself is not a pointer, but array, the name of the array functions like a pointer. It points to the first element. What do I mean by that? Recall in our previous sections how we treated concepts like this. How that a pointer, let's say a pointer like this. When you declare a pointer of int, let's say you declare, first of all, there's a variable here, let's call this int n, right? And then you declare a pointer int p. The pointer has to be the same data type with the variable, right? And so each time when you come here and say that p is equal to the address of n, right? Now, once you've done this, anytime you call p, you will print the address of n. This also means that when you put asterisk and put p, it is equal to n. That means if n is 10, asterisk p will be 10. Right? I assume that you've seen the other videos, so let me not talk much about that. In the same way, this name numbers, right, is equal to the address of numbers 0. It has the address, memory address saved inside it. Very interesting, right? So if I want to know the address of this guy, I can just print numbers and I'll get the address. I will demonstrate that shortly. So then it then means that, since we have the address of the first one, that means I can have the address of the other ones. I should be able to have the address of the other ones. Is that possible? Is that actually possible? We'll find out. Let's code. Do I want to increase this comment to this way? Let's now work with addresses. So let me get the comment to this point and then copy this printf statement and have it here. Our program is getting longer. Just in right. I will say address of numbers 0 is percentage %p because we want to print memory address. And now let's just give it numbers and see what happens. I'm talking about pointers versus array, right? What is the relationship between pointers and array? I think I want to add it here. Pointers versus array. Pointers versus arrays. Can we take this out of here? Stay here. Okay, back to our code. Okay, so let's see what happens here. Want to see? Interesting. Save this, go to the background, compile again, but this time I want to call the executable arrays and pointers. Pointers, let's call this mem address. Let me just call it mem address. Alright, it compiled without error. The file is here. I hope this is big enough. Should I make it larger? Okay. Okay, so let's run that program. Interesting. It's printing the memory address. It's printing the memory address. Remember, what to pass was a name, right? Maybe I should put it this way. Just so we know that was what we did. Numbers. Compile again. Run it again. So numbers is printing this stuff. It's printing the address. And you know that the address is different each time you run the program. The address will be different because the address is assigned at runtime. That's quite interesting. That's quite interesting. All right, what next I want to tell about pointers about this? Now, I think we should talk about pointers arithmetic. Pointers arithmetic. Yeah. Now, see, I'm going to be arithmetic with this stuff right now. Since this guy points to the address of the first guy, that means 1 is saved at this address. Okay, let's find out. Let's just experiment some more to find out whether it's the same thing. Let's add another printf statement here. Let's see what will. I think I prefer copying this one here. What will and you're going to put ampersand numbers 0 print. You know, ampersand stands for address of, right? When you see ampersand like this, ampersand anything, for example, if you see something like ampersand n, this means address of n, the variable n. Okay, so I'm trying to check for the address of this 0. Let's see whether it will be the same thing with what this guy is printing. Let's see whether it will be the same thing. Ready? Save, minimize, compile again. Yes, problem. What's that? Numbers. Oh, I didn't put anything inside it. It's not complete. I'm looking for the address of 0, so let me put 0 here. Alright. Clear the screen for me. Compile that again. It compiled now, no error. Let's run it again. You can see exactly the same thing. Exactly the same thing. Now let's go. Let's do something arithmetic. This then mean that if I want, I can access the other value using this guy here that is now the pointer working for us here. That's now working like a pointer. I can access the other values using it. How? Let me paste this here. What did I do? Uh-oh. Copy this for me. Paste it here. Now, how do I get that again? Let's find out. Let's find out. Remember, we get what is stored. Let's see what happens if I do pointer numbers plus 1. What will happen if I do numbers point plus 1? What will it print for me? Let's also have it here so that we know that that's what it's bringing out. Numbers plus 1. I think I don't want this one for now, so I'll comment it off. Save this. Go here. People that say I used to be too fast, I think now I'm slow. I'm slow enough. It compiled, no error. Let's see. So number plus 1 is giving us the address of this guy. Are you seeing that? Number plus 1 is that not the way pointers behave? Numbers plus 1 is giving us the address of the next one. And if you check the 2, the difference is 4. I don't want to start, is it 4? This is C, A, B, C, 10, 11, this is 12. 12 plus, they'll put 1 here. Okay, let's make it clearer. Let's do some more. Let's have several of them. Like we want to print out the entire address. So I'll copy this. I'll yank it here. And let's do plus 2. Plus 2. Remember, anyway, we'll find out shortly. We'll find out something. Let's compile again. No error. Let's run it. Okay, so it's clear now. It's adding 4. Look at this is 0. This is 4. Look at it. Everything here is the same. Everything here is the same at this point. The difference is that he added 4 to get that. So it went 4 bytes further to get the other one. It went 4 bytes further to get. You may not understand it using this CC stuff. So this is where we have 0, number 0, the index 0. This is index 1, element at index 1, and this is the element at index 2. They are 4. Let me run it again. Let's see whether we have the one that's easy for us to calculate. Come on, give me some decimal value at the end now. Who's gonna use stubborn? Okay. Anyway, it's fine. So it is adding 4. That's what is happening. It's adding 4 to get the next one. 4 bytes to get the next one. And let's just do some more comparison. If I change this to let's find out the address of the guy at index 2. Let's see whether this one at line 25 and the one at line 26 will print the same thing. So I'll save it. I'll compile that stuff again. I will clear the screen and I will run the executable. Look at that. So this guy plus 2 is going to print the element at index 2, which is the third element, which is actually, sorry, it's going to print the address of it, right? Which is actually what this guy stands for, ampersand of that thing, address of this. So this guy is working like pointers. So if it's able to work as pointers, we should be able to, the way that we can add asterisks to the name of a pointer and it will give us the value, then this guy should give us the value as well, right? What I mean is this. Let's just use plus 2 here, plus 2 here, and then let's say we want this one to give us the value. Usually you just add asterisk to pointer, right? And then it gives you the value there. Let's find out whether it will work like that here. I'm going to comment this first line off. I don't need it to run now. And then let's just work with the element at index 2. And let's compare it with what will happen, what the sound will do to us. what does someone do for us rather? Let's just play. This is where you learning actually takes place. It's not in passing some projects and earning some scores. This is where the learning happens. Let's just experiment. So no, I think I wrongly placed this. Is it correct? This is giving us the address. Okay, so we are comparing it with this one, so it's correct. It's correct. So I'll yank it here. Then this other one is giving us the value. We are expecting it to give us the value. Let's see how it will work, and then let's compare it with this. So if this works, it should give us the address, and this one should also give us the address. Then this one should give us the value there, and this one should always give us the value there. Let's save that. Compile. Plenty of errors. What is matter? Okay, I'm using percentage P. Sometimes you see plenty of errors like this. You'll be thinking one big thing. You'll be thinking you're finished. Not knowing it's just one thing, right? Since I'm printing values here, I should use percentage D, right? Percentage D. Save this. Go. Clear this screen for me, Joe. And then here we go. Okay. Can you see that? That this guy is printing the address and this guy is printing the address. Right? So when we add asterisks to this guy, just the way we add asterisks to pointer to get the value, we get the value. Isn't that pointer behavior? This is pointers versus arrays. And this is pointers arithmetic. Right? So numbers too is also giving us the value as expected. Isn't that interesting? It then means that numbers 2 is equal to asterisk numbers plus 2. Right? Let me see that on our board. Let me just write that down on our board. So okay, let me continue with this stuff here. I think I need to take off. Okay. Here we found out that the way numbers 2 prints the element at index 2 is equal to the way what we get when we evaluate numbers plus 2. Now, why am I putting the bracket here? I want this guy to evaluate first before adding this guy. That's why I'm putting the bracket. I want it to evaluate first before adding this guy. What will happen if I don't put the bracket? Let's find out. What will happen if I don't put the bracket? Okay. Watch this. Interesting, right? Let me take this bracket off here. Okay, let me copy this and have another one without the bracket. I'll paste it under here, and then I'll take off the bracket, and then come here as well, so we know which one is printing what. So let's compile that again. Compile, no error. Let's run it. Watch this. Without the brackets, it will first go, this guy, this asterisk numbers will not go for the value of the first element. Okay, how do I do this? Let's do this. Let's do this. Let me change the element at index 1. Let's change it to 10 so you see what happened. This is how I learn. Like, I just play with the stuff. I do extra things with it. See what play with it. Now change it to 10, right? I changed it to 10. Oh, remember, okay, what is okay? Let me do it this way. Let me rather do it this way. Let me go back and change it to 1. So undo and come back here, and here there was a place where I changed. Where's that guy? Okay. Let me rather copy this stuff. It's okay, Topman, calm down. Let's have it that way. I'm just trying to make it as simple as possible because I don't want to do anything too complex to get someone confused. Now the element at index 1 is 10. You're aware that is 10. Let's now come here and compile this again. It compile without error. I'm going to clear this screen and I'm going to run that executable. Watch this. How come? What is happening here? Why am I getting 12? Why are we getting 12 here? You know why? Asterisk numbers, since numbers on its own, on its own has the address of the first element, the element at index position 0. Alright? Then if you add asterisks to numbers, it should give us the value there. And now the value here is 10. So what we are doing here is 10 plus 2. 10 plus 2 equals 12. 10 plus 2 equals 12. Meanwhile, what we are doing here is this one will evaluate first. That's why we put it inside brackets. So it will evaluate first. It will be numbers plus 2. That means the address move 2 times plus 2, and each of these 2 will be representing each of these 2 will be 2 times 4. That is 8 bytes. So it will be numbers plus 2 bytes. I hope I did not confuse anybody. This guy in this square bracket represents bytes, right? So as it is 2 here, this thing means 2 times 4. So when you put this 2 here like this, and you want to add it with an address, it will not see it as figure 2. It will see it as 2 times 4, because you're dealing with a 4 bytes. You're dealing with something, each of which stands for 4 bytes. So it will add 8 bytes and go that way, and then before you now add this asterisk and get the value there. Whereas if you didn't do that, this one will evaluate first before adding this. So it will first evaluate and get a value, and now say this 2 as ordinary 2. So when it gets to 10, it adds this 2. Whereas if it's in the bracket like this, it will find out what this is, which is an address value. It will go here and not take this as ordinary 2. It will take this as you're referring to some size. So if you say 2 times 8, it will not add that 8 to the value, to the address value here, and then it will now evaluate this one. Asterisk could make it print the value saved at that index position. I hope that was clear enough. Now string works the same way, so I'm not going to spend plenty of time talking about string. String works just the same way. String works the same way. I think this file is compacted enough. Let me not add more. I'm going to close this file and start another one. Yeah, so yeah, we still have only one file. This why pointers.c, and from there we generated these executable files. Interesting, isn't it? So let's have another one. Let's call this one string.c. Okay, I don't like typing plenty, so let's copy what we have in pointers into strings.c. Okay, I'll do this first. I'll save this first, minimize it, come here, yank this. Okay, so it's copied now. I'll now go into this editor, don't worry about what I'm doing, and open the file with that content. So yes, alright, so you have all of this. I'm now start deleting all the things that we don't need. Meta key. Alright, here we go with the basic boilerplate of C. Now let's declare string. What is a string? A string is an array of characters. Let me write that on the board. A string is an array of characters. Are you sure I'm going to complete this here? This is taking longer than I expect. So string. A string is an array of characters. Alright. What do I mean by that? What do I really mean by that? I mean that the same way you do int something, let me say car letters. Look at this, looking similar. I put bracket here. I want to have 3 letters, so I put 3 letters. Then I say equal to, I open my and close my curly braces, right? And I have C, A, R. These are the three characters I want to have, but this will be invalid. You know, the way I will indicate that they are characters is to enclose them in single quotes. So single quote here, single quote here, single quote here. Remember, compare it to when we had 1, 2, 3. This is an array of integers. Yeah, this is an array of integers. This is an array of characters. Right? Let me even type the full thing so that it will make sense. I need to end this with a semicolon so you can compare them. Right? So let's do this. Let's say int numbers having size 3 is equal to this, and then end it with semicolon, and then I want it as a comment. Okay, just comment it off. All right, isn't that right? That's what it means. It's an array. Putting in an array different characters forms a string. In this case, do I need to iterate through it to print it out? Let's find out. String itself has a format specifier used in printing it. So if I just go %s, I'd like to add a new line, and let's say give it the name of the string. Let's see what happens. So I'm going to this time I may have only one file. So I'm using this make command is as good as doing GCC. You can see what happened. CC this. So don't be confused. Right? Don't be confused. It's something that's doing GCC string dot C -o string. Right? All right. Thank you. Now let's now run the executable. Is it here? It's there. I'm going to clear this screen. Show you again. It's there now. Look at it. String. You can see car is printed. Unlike array, you couldn't put name of an array like to print. That's one difference, one big difference between strings. You know, working with strings and working with car. All right, take note of that. Take note. It's very important. Let's go back. So if it was an array, you couldn't put. You recall when I put numbers here. Oh, you know, if I try to put numbers here, you couldn't. You can try it. Yeah, when I see what happens, open your sandbox, play with it. Play with it. You can crash it and destroy it and refresh it. And nothing will happen except, so long as you've gotten to this point, nothing will happen if you destroy a sandbox. Nothing. Just make sure you don't have a data that you don't want to lose. You know, data every push your data to Git, you know, to GitHub and play with it, crash it, restore it again. Okay. Now, of course, using a loop to print these guys would be a waste of time. Another way I could have done this, right? Instead of doing this, what if I want to have a long sentence? What if it was a long sentence? Would I now start putting this one like this? If I wanted to type my father has a car, and I'll be doing should I do it? I don't have enough time. I don't have enough time. You know, that's why you know that even space is a character, right? If I want to put my car, I will now put M here, and now put comma, and put Y here, and now put comma, and put space here, and then put comma, and then because I've added 1, 2, 3 more characters, I'll come and indicate here that I have 6 characters inside here, right? 6 characters inside here. What stress? Then imagine if I wanted to write my father has a car. Imagine what it will take me. What it will cost me. Fine, undo now. See by force. I don't want you. Alright. So that makes us want to consider this other way of declaring a string. Car letters 3. And instead of putting that, showing that it's an array of characters, you can just put double string here and put the whole characters inside that place. Now I can't have 2 variables with the same thing, right? So let me comment this one off as well and use only this one and see whether it will work. right? Let me call it okay, let me even call this one card 2, say card 2, letters 2, and call it card 2, and then try to print letters and then try to print letters 2. Let me indicate here that this one is for letters, and let me indicate here that this one is for letters 2. Okay, let's see whether this will work well. Compile that again. What is the matter with you? It's too long. Okay. Letters 2 has an additional character now, so it's 4 characters here. 4 characters. So let's say, come. You know, these mistakes, I'm glad they're happening here. They're making us learn, right? They're making us learn. So let's run it now again. I've compiled successfully. Where is it? Run it. Alright. Aha! I say mistakes help us learn. So what is happening here? What is happening here? I will tell you what is happening. Now what happened is this. Strings terminate with null bytes. So I was supposed to add a null byte here. /0. Because it didn't meet this null byte, this printf did not meet this null byte, it continued, it didn't stop. It went. So it met the null byte here, that was why it stopped. It printed the car and continued to the car 2. That was why we had it as this. That's that guy. Car 2. Car 2. So it didn't stop because I didn't add this null byte. Now that I've added the null byte, I will now go and say, hello, it's now 4 characters that I gave you. Stop adding null byte. See what will happen now. This is like instructions to stop here. Because it was this printf I refused to listen. I went and printed until it met the null byte of the second one. Why? This one automatically adds the null byte for you. Automatically adds the null byte for you. Right? Without requiring you to add 5 here and say, okay, if I have 5 characters. So this is the terminating byte, the bus stop, the full stop, you know. Right, let's go and print again and see what will happen. So make string, normal error, string. Look at that. Now it stopped there because it saw the null byte. Car 2. Isn't that interesting? Isn't that so interesting? I think apart from these things, every other thing that I can remember now about string and array, they look alike. They look alike. They look alike. You can have multidimensional arrays, so you can have multidimensional strings. I can have an array of strings, not an array of characters now, an array of different strings inside there. But let's not make this complex, right? Let's not make this complex. I actually intended to solve some examples, not just talk. So for instance, in case you're an ALX student, you can watch and say, after watching, I now understood very well, and I went to the project, I was now confused. Now we pass through all of those stuff. I started as a newbie in the ALX. Is my first experience with codes. First experience with programming. You know, I think I won't say with code because I knew HTML before coming to. So HTML is not a programming language actually. Yeah, so it's my first programming experience. So I appreciate all of that. I appreciate reading and watching tutorials, and you're enjoying yourself, and you go back to your project and everything is strange. That's why I enjoy solving some examples that will not be exactly what you have on the internet, but something that when you look at it and you understand how I did it, you can go to the internet and do what you have there, you know. But I think I will continue. I'll continue this section later. I mean, I can't help it. I can't help it. So I will talk more if there's something about strings I have not talked. I think this is about all the basic things about strings. If I go beyond this now, I may get you confused. So let me stop here for now. Let's just say in the next episode, in the next section, I'm going to be talking about the importance of arrays. Yeah, and then I'm going to be solving some examples on pointers, arrays, and strings. You don't want to miss it. You don't want to miss it. Thank you very much, and please show some support. Like, right? Like the video. Don't just like it. In case you downloaded it from YouTube, go back to the place where it is on YouTube and click like. Let YouTube know that this video is impactful. Put some comments. Right? You can share with others. Let others learn as well. Right? And do subscribe to this YouTube channel if you're not subscribed. You can connect with me on Facebook, Twitter, LinkedIn. I have the same username on all of this platform. Yeah, Paul-Dike, like Paul-Dike. That's the username, right? And I invite you. You can be part of the live audience. Yeah, in case you want to, just contact me, and I will let you know how to participate in the live audience and not just see the videos on YouTube. Thank you very much. God bless you. See you some other time.